So then, what are the additional steps in manufacturing a microchip? Before chip manufacturing at the fab, we first have to manufacture the silicon wafers by refining quartzite into pure silicon, and then growing a monocrystalline ingot and cutting it into wafers. For reference, these 300 millimeter wafers are around 3/4 of a millimeter thick. They have a barcode on the side and a small notch in them to indicate the direction of the crystal lattice. Furthermore, these wafers are incredibly delicate and shatter into hundreds of shards when broken. A single wafer costs around $100, but after being populated with CPUs, it's worth closer to $100,000, making it quite literally 10 times more valuable than its weight in gold. Moving on to the steps after chip manufacturing. The completed wafer is sent to a separate building where each of the CPUs undergoes rigorous testing to figure out if it works as intended. If a CPU works, that's great. But frequently, a particle or photomass defect has damaged a section of the integrated circuit, rendering that section defective. These semi-functional circuits are then categorized or binned based on what still works. These Intel 13th Gen processors are sold as an i9, i7, i5, or i3, depending on how many cores are functional with different product lines of CPUs whose onboard integrated graphics sections are defective.